Hello, Mr. Aaron, Mr. Ryan, are you right? Yeah?
Definitely.
Definitely. Okay. 4 and 7 are lucky number. Let's just assume, right?
I don't think 4 is a lucky number.
Okay, so maybe let's change it to 6 and 8, okay?
No, I think it should be 7 and 8.
Yeah, 7 and 8.
If you watch your number blocks, then you know why 7 is a lucky number. And,
Okay.
And in Chinese, 8 is.
Yeah, of course. Okay, so 7 and 8 are lucky numbers. We consider a number lucky if it only contains these two digits. Okay, so for example, the first lucky number from the small to the largest. First one is 7, next one is 8. What's next? Which has only 7 or 8?
78.
78? What's here? You can reuse the digit.
77.
That's right, yeah, 77, okay?
You didn't say, you just said only using 7 and 8.
7 or 8, okay? So 7, 8, 77, 78, 78, what's next?
87 and 88.
87 and 88. And what's next?
7, 87. No. Is it 777?
7, 7, 7, 7.
778. 778, yeah.
Yeah, okay. And what's next? 787, right? 788, okay? So, do you find the pattern? So, we want to find out, we're given a k, we want to find out the k's lucky number. For example, if k equals 5, then you need to tell me is this one, because 1, 2, 3, 4, 5. K equals 7, you need to tell me is this one. Any idea how we can solve this? How do you construct this k lucky number? There are only 2 digits, 2 lucky numbers. There are only 2. Let me write it in the table. So you tell me what can we find, okay?
Is it something to do with a number and...
K equals 1. This is K, right? K. This is the lucky number.
Lucy.
Lucky number. K equals 1. Start with 1. Is 7. 2. 8. 3. 77. 4. 78. 5. 88. Right? 6.
There's 87 and then 88.
Yeah, 87. Okay. 88. 8. 7, 7, 8. 9. 7, 8, 7. 10. 7, 8, 8. Okay? There are only 2 possibilities. 7 and 8. If I say this is binary, remember the binary is 0 and 1 thing. 1, this is 1, 0. 4 is 1, 0, 0. 5 is 1, 0, 1. 1, 0, 0. 1, 1, 1. 1, 0, 0, 0.
That was I was kind of saying.
So the 9th is 1, 0, 0, 1. And the 10 is 1, 0, 1.
Just tell us a pattern. For the last digit, like 7, 8, 7, 8, 7, 8, 7, blah blah. This one is 7, 7, 8, 8, 7, 7, 8, 8. Yeah. And then the last digit is like 7, 7, 7, 7, and then 8, 8, 8, 8. So for the last digit, it 1 and then the other, and this is the second digit is 2 and then the other, and then this and then the third one is like 4 and then the other. Yeah.
Okay, so
this one starts 2 after the first one, and this starts 4 after that one.
Yeah, I was trying to.
Yeah, you see, because this is 7, 8, 7, 7, 7, 8. And is one after the other, and this one is 7, 7, 8, 8, 7. So it's 2 after the other, and it's the second digit. And this one and it's 2, 2, 2, and then it also starts 2 after the first one, and then this one is 7, 7, 7, and then 8, 8, 8, 8, and then this one starts 4 after the second one.
Okay.
Okay.
It's very difficult to find a pattern, right? But if I draw this, look at this is magic. Okay?
I already seen it. I see a pattern already. I already told you my.
Okay, can you say it again? What's the pattern? Can you? Because I didn't follow that. What's the pattern?
Okay.
You're not listening.
Yeah, you are listening.
Okay, please.
I said it twice even.
Okay,
I said it directly to you.
Yeah,
I was like.
Okay, can you say it
So
again?
the last digit is 7, 8, 7, 8, 7, 8, 7, 8. I already told you that
Yeah.
before. And then the second digit is 7, 7, 8, 8, 7, 7, 8, 8.
Yeah.
It's 2 after the other. Last one is 1 after, and this one is 7, 7, 7, 7, and then
Yeah.
8, 8, 8, 8. And this one it starts 2 after, and and it's 2, 2, 2, 2. And this one is 4, 4, 4, 4.
Okay.
And it starts 4 after the second one.
Yeah, this is binary. Yeah, this is the number we talk about this binary, right? Okay, so yeah, I understand that, but it's not easy to implement using your approach. Let me draw this. Okay, let me
It's a
draw this.
pattern though.
Let me draw this.
Yeah, that's 7, 8, 7, 8, 7, 8. We can sort it out.
What can we get if I draw it this way?
So 0, 7, and
So okay, so which number corresponds to 7?
0.
Which number corresponds to 8? This
One.
one we know how to convert the number to binary. We can use the Python bin function. And we just have to replace 0 to
Why do
7,
you have to
1
go
to 8.
to the binary in front of and throw in the
Because
bit?
the first number is 0 and we don't have anything here. 0. 0 is the starting point. 0 is not a lucky number. We have to skip it. Right? But that's a very good question. This is the pattern, right? Okay. Why can we do this? Because there are only 2 lucky numbers. And in binary we have 0 and 1. Okay, so we can do this one-to-one mapping. This problem can be solved using other approach. We're going to talk about other approaches in the next few lessons, but this is the most straightforward. We find a pattern. There are 2 numbers, 0 map to 7, 1 map to 8. We have to skip the first one because the 0 is not a lucky number, but in binary, 0 is the first number, okay?
Yeah.
The bin function, for example, like bin 7. What do we have? Bin 7 in Python, you give a string 0, B111. We skip the first 2. Define f, and we want to return the lucky number as a string type, like 777. Fk, and we want to. This is the returning a string str. Okay, so the binary, right? We need to use the binary. So because look, if we want to find out this, the 8th lucky number, right? 8th lucky number, then we have to find out this, right? K equals 1, we need to get this k plus 1, right? And then this.
And then remove the first
Right,
one.
k equals 7, we need to get this number first and remove the first digit, right? So s equals bin function k plus 1. This is returning the string 0b something something something, right? But we have to skip these first characters. Okay, so skip the first character. So it start with 0, 1, 2, 3. We start with this, the 4th characters. Okay, and then we just need to return s dot replace function, string replace. We want to replace the string 0, character 0 to 7, and then we need to do another replace 1 to 8.
Yes.
Yeah, and that's it. Converting integer k to binary is log k. This is log k. The string now is log k length, and we need to do two linear search to replace the character. Times 3, actually times 3, and we drop a constant. Actually, is log k. Okay. Yeah. How do we convert the 10 to binary? How do we convert 10 to binary, which is 1010? Do you still remember? Look, this 10 divided by 2 is 5, remaining 0. 5 divided by 2 equals 2, remaining 1. 2 divided by 2 equals 1, remaining 0. 1 divided by 2, 0, remaining 1. When we get a 0, then we write down the numbers in the reverse order. So the binary for 10 is 1010. Okay, let's try another example. 27 in binary. What's 27 in binary? 27, okay? 27 divided by 2 is 13, remaining 1. 13 divided by 2 is 6, remaining 1. 6 divided by 2 is 3, remaining 0. 3 divided by 2 is 1, remaining 1. 1 divided by 2 is 0, remaining 1, right? When we got the 0, we stop, and the binary is 11011. Okay, so it's 11011. So how do we verify this is 27? This is 1, this is 2, this is 4, this is 8, This is 16, so it's 16 plus 8. We skip these 4 because this is 0. Plus 2 plus 1. 24, 3, 27. As I said, there are many ways to solve this problem, okay? Today we talk about this binary because we find out that in binary, any number in binary has only 2 digits, 1 and 0. And there are 2 lucky numbers, which is 7 and 8. So we can kind of do this in one-to-one mapping. What have you learned today?
We learned about lucky numbers. About the lucky numbers, and we're trying to find a cake.
Try to find the K. How do we do it? Come on.
A cake.
Yeah. There we go.
We do like these binary converters.
We have 2 lucky numbers, supposedly. 2 lucky numbers, which are 7 and 8.
Yeah.
We've been given K, and we're trying to figure out the K number, lucky number.
And how do we do this?
The
Yeah.
lucky numbers are using the digits of the 2 lucky numbers, 7 and 8. And how we work it out is we get K plus 1 in binary, and then we just remove the first digit, and then 7 is 0 and 8 is 1.
Yeah.
And then we just convert it back, and then you get the lucky number.
Excellent. Yes, we just do the one-to-one character substitution. Yeah, substitution to replace. We talk about this string replace. Yeah? To replace from 0 to 7, from 1 to 8, and we can do this. We need to do this twice. Okay. That's it for today. Bye bye.
Bye bye.
Bye bye. See you next week.
Bye bye.